Hello, this is team number 2 explaining how to solve a system of equations using Cramer's rule or Cramer's method. First, we have to pick a system of equations that has the same number of variables than the number of equations. For example, we have a system of equations that has 3 variables and we have 3 equations as well. So the first thing we have to know is we are going to use cofactors. So a very important thing to use for when using cofactors is the rule that has the rule of the signs. We're going to be performing operations with square determinants, and we have to use these signs. For example, you have your first row, and if you want to use those numbers as your cofactors, then you have to use these signs. And then if you want to use the ones in the second row, you will need to use these signs. And in the third row, it repeats, and so on and so on. Obviously, this depends on the number of variables in equations that you have. If you have 7, you will have to add negative and then positive and then negative and then positive and so on until you reach, and then here positive, positive, negative, and so on. So now that you know this, then we have to build our matrix. This will be our general matrix, which will help to get the determinant of the system. That this Cramer method is based on determinants. We have to get 3 determinants. In this case, we're going to use cofactors to get them. And first, we have to build this matrix. In this case, we start by doing the general. We can start by doing the specific matrices, but we have then the coefficients of the variables. Here we have 3x, minus x, and 2x. So we write them, then we write the y's and the c's. This is a column that we will use to replace for when we want to know a specific value for a determinant. That will come later. So then we use our determinant, which will be the same as this matrix in terms of elements. Then when we compute this determinant using the cofactor method, we take a cofactor, which in this case will be 3, and perform 2 times 2 operations in a determinant that will be smaller. In this case, we have 3, which is our cofactor, and because we chose the top row, the sign of the cofactor will be positive. Then we multiply this one times this one, and subtract this one times this one. And all that operation has to go inside of a parenthesis, and then at the end will be multiplied by the cofactor. So we perform the operation of this matrix, which is the one I just told you. We have 12, then we have -9 for this other matrix, this other determinant, and for the final 2 by 2 determinant, we have -4. So now we multiply each of the cofactors by the multiplication or operation of each smaller determinant. So we compute, and then we have as a general determinant 74. In this method, to get the variables, we have to find each determinant for each variable, and then we have to find also the general determinant. Then we find the next step after finding this general determinant, which is commonly written as delta, which is a Greek letter, subscript S, which stands for system, determinant of the system also. So then we find the other 3 determinants. In our case, because we have 3 times 3 system of equations. So then we build our new matrix, but since we want to find first the x, we substitute the column that had the x's, the coefficients, by the column B, which we built before with the results of each of the equations. Here it is 5, 6, and -10. So you change that column into this matrix or this determinant, which will be the x determinant. You perform the same operations with the same rules and the same method for the cofactors. Then you you compute. In the end, the x determinant will be the following. Well, after computing, we get these values, then we multiply them by their cofactors. And in the end, the determinant for x is negative 104. So now that we have done that, we pass on to the next determinant, which will be y. And the column we previously substituted in the column of the x's will now be substituted in the column of the y's, and we have to return the column of the x's. So we will have the column of the x's, then the column b, and then the column of the c. So we perform the same operations. After performing the operations that we have here, for each smaller or minor determinant, we have these values that add up or sum up to 181, which will be the determinant for y. And finally, we have our third determinant for the variables. We have the third matrix that we have it here. Then we expand and compute. We have negative 16, negative 2, and negative 4 for each of the smaller or minor determinants. Multiply them by the cofactors, then we have negative 64. So finally, the last step to solving the system of equations is use the Cramer rule, which means the determinant or for each variable over the determinant of the general or the determinant of the system will give you the value of each of the variables in the system. So we apply this and then we substitute. The x will be the determinant of x, which is negative 104 over the general determinant, which is 74. Then the y will be 181, which is the determinant for y, and divided by the determinant of the system, 74, and the same with c, negative 64 over 74. So finally, we simplify and we get these values, and this is actually the final solution.